One more day on parametric relations and inverses. Okay, so the inverse composition rule. A function f is one-to-one with inverse function g if and only if f of g of x equals x for every x in the domain of g, and g of f of x equals x for every x in the domain of f. What that means is when you take the composition and you simplify it, it's got to come out to be the identity function, or they are not inverse functions to each other. So it says show algebraically that f and g are inverse functions. To show that they are inverse functions, we have to find f of g of x, and we have to find g of f of x. And if they both come out to be x, then we got it. So to do f of g of x, we start with g of x, which is the cube root of x minus 1, and we take that to the f function. So I'm taking the cube root of x minus 1. The f function says to cube whatever you got and add 1 to it. Well, I brought the cube root of x minus 1. A cube kills a cube root. That gives me x minus 1 plus 1. The ones cancel, and I get the identity. So far, so good. But I still don't know if they're inverses until the other one checks out. So I have to find g of f of x. So I'm starting with f of x this time, which is x cubed plus 1. And I'm taking it to the g function. The g function says cube root of whatever you brought minus 1. And I'm bringing x cubed plus 1. Simplify, the ones cancel, and I have the cube root of x cubed. Those cancel, and I get the identity. So since both of them, then yes, I've proven that those two functions are inverses to each other. And you can tell by the graph, there's my first cube, second cube, mother right in the middle. Alright, so you decide if these are inverses or not. Hit pause, come back when you're ready. And hopefully you got yes. Alright, in order for them to be inverses, I have to find f of g of x and g of f of x. And to do this one, we're starting with g first, which is the square root of 3 plus x. And we're taking it to f, which says square what you brought and subtract 3. I brought the square root of 3 plus x. The square kills the square root. I get 3 plus x minus 3. The 3's cancel, and I get the identity. So far, so good. For g of f of x, I'm going to start with f of x, which is x squared minus 3, and I'm going to go to g. And g says square root of 3 plus whatever you brought. And I'm bringing x squared minus 3. Simplify, the 3's cancel. I get the square root of x squared, which is just x, which is the identity, so it checks, and yes, they're inverses. Okay, and if you look, there's my parabola, there's my half a parabola, and you see where they intersect, so does mother. Alright, they're going to get a little more complicated because of these fractions. Alright, just relax, they're not that bad. Alright, so if I'm going to do f of g of x and g of f of x, for this one, we're going to start with g, which is x minus 3 over 9. And we're going to go to f, which says 9 times whatever you brought plus 3. I brought x minus 3 over 9. Now, you could multiply that all out if you want to, but isn't a multiplication 9 going to cancel out a division 9? Which leaves x minus 3 plus 3, which makes those cancel, which gives me the identity, so we're halfway home. Okay, so now we got to find g of f of x, which means I'm starting with the f function, which is 9x plus 3, and taking it to g. G says whatever you brought, subtract 3 and divide by 9. Well, I brought 9x plus 3. The 3's cancel. That leaves me 9x over 9, which does leave me with x, which is the identity. They both checked. So yes, they are inverses. Okay? And you can see when I graph them that they are. Alright, confirm that these are inverses to each other. So we have to find f of g of x, and we have to find g of f of x. For this one, we're going to start with g, which is 3 over x minus 1, and take it to f. F says, whatever you brought, add 3 to it and divide by it. So I brought 3 over x minus 1, which I put here and here. Now, to simplify this mess, on top, you can't, I want to keep change flip, but I can't keep change flip until I do the math on top, which means I'm going to need a common denominator, which is going to be x minus 1. So I multiply the top and the bottom by x minus 1. That gives me 3. On top, it'll give me 3x minus 3 over x minus 1. Switch colors here. So now on top, I can combine like terms, which is going to be 3 plus 3x minus 3 over x minus 1, all over 3 over x minus 1. Those 3's cancel. So now that I've simplified the top, I can keep, change, flip. So I'm going to keep 3x over x minus 1, change to times, flip the bottom, x minus 1 over 3. These cancel, and I get 3x over 3, which just gives me x. So far I can say yes, but I got to prove that the other one is true. So we're going to start with f of x on this one, which is x plus 3 over x, and we're going to g. G says 3 over whatever you brought minus 1. I brought x plus 3 over x. Oops, I can't keep change flip because I got to simplify that bottom, which means I'm going to need a common denominator, which is going to be x. So that gives me 3 over x plus 3 over x minus x over x. Combine the tops, I get 3 over x plus 3 minus x over x. Those x's cancel. I get 3 over x. Now I can finally keep, change, flip. So keep the 3, change the times, flip the fraction. The 3's cancel. I get x, which is the identity, which means yes, these are inverses. Okay? And you can tell by the picture. See how the boomerangs intersected and mom intersects where they intersect? Pretty cool. Alright, let's look at this one. If I find f of g of, x, and I find g of f of x, let's see what I get. We're going to start with g here. G is x minus 3 over 2. Taking it to f, f says 3 times whatever you brought minus 2. I brought x minus 3 over 2. Yeah. So this would give me 3x minus 9 over 2 minus 2. When you multiply, you don't multiply the top and the bottom, just the top. Okay? This does not equal x, nor will it equal x, so these are not inverses. I don't even have to check the other one. Even if the other one works, this one didn't, which means they are not inverses. And you can tell. There's one, there's the other, there's mother. She doesn't intersect where they intersect, so no can do. Alright, so if we look at this one, give me just a second. Alright, I'm back. Okay, so we're trying to decide whether these are functions or not. Well, we're going to have to find f of g of x and g of f of x and see what we get. So if I'm doing f of g of x, I'm going to start with g, which is negative 3x minus 7 over x minus 1. And take it to f, and f says whatever you brought minus 7 over whatever you brought plus 3. I brought negative 3x minus 7 over x minus 1. So negative 3x minus 7 over x minus 1. Negative 3x minus 7 over x minus 1. I got to simplify those tops, which means I need common denominators, which are going to be x minus 1. So that would give me negative 3x minus 7 over x minus 1 minus 7x minus 7 over x minus 1 all over negative 3x minus 7 over x minus 1 plus 3x minus 3 over x minus 1. Combine like terms, that's going to give me, keep the x minus 1, I'm going to have negative 3x minus 7 minus 7x plus 7, because you got to distribute the negative. So that's going to give me negative 10x, and the 7's cancel. So I'm negative 10x over x minus 1, that's on top. On bottom, this is going to give me negative 3x minus 7 plus 3x minus 3. The 3x's cancel and I get negative 10 over x minus 1. And now I can finally keep, change, flip. That gives me negative 10x over x minus 1 times x minus 1 over negative 10. Those cancel. The negative 10's cancel. And I end up with the identity. So far, so good. Now I just have to do g of f of x, which means I'm starting at f of x. There's the picture. Which says x minus 7 over x plus 3. And I'm taking that to g. G says negative 3 times what you brought minus 7 over what you brought minus 1. I brought x minus 7 over x plus 3, x minus 7 over x plus 3, x minus 7 over x plus 3. Alright, and to simplify this mess, on top I'm going to have negative 3x plus 21 over x plus 3. I'm going to need a common denominator, which is going to be x plus 3, which is going to give me a minus 7x. What am I doing? X plus 3? Plus 3? Plus 21 over x plus 3. On bottom, I'm going to have common denominator, multiplied by x plus 3, x plus 3. I'm going to have x minus 7 over x plus 3 minus x plus 3 over x plus 3. Phew. Alright, on top we have the same denominator, so I'm going to keep the x plus 3. I have negative 3x plus 21. The minus is going to change their sign, so that's going to be minus 7x minus 21. The 21's cancel, and I get negative 10x on top. Okay, so there's my top. Now my bottom, I'm going to have x minus 7 minus x minus 3. Got to distribute the negative. The x's cancel, and I end up with negative 10 over x plus 3. Keep, change, flip. I get negative 10x over x plus 3 times x plus 3 over negative 10. Cancel, cancel. I get the identity on both compositions, so yes, these are inverses. And if, oh, here's the other thing I want to show you. The other way you can tell functions are inverses graphically is, remember I told you mother doesn't have to intersect where they do, but do you see how she is, this half is exactly the same as this half reflected over? It's still the mirror image of whatever's over here happens over here. Alright, so you decide whether these are inverses, hit pause, come back when you're ready. We can look at the picture and tell now. And hopefully you got yes. One thing you can do is just type in the graph in calculator and look at the graph. Here's one, here's the other. Mama intersects where they do. You're good. Alright, but let's do it algebraically. So I have to find f of g of x, and I have to find g of f of x. To do this, we start with the g function, which says 6x minus 4, and we go to f. The f function says, whatever you brought, add 4, divide by 6. I brought 6x minus 4. Well, the 4's cancel, and I'm left with 6x divided by 6, which is the mother function, so we're halfway there. The other side, I got to start with f of x, which is x plus 4 over 6, and I have to go to g, and g says 6 times whatever you bring minus 4. I'm bringing x plus 4 over 6. The multiplication and division 6 cancel, and I'm left with x plus 4 minus 4. They cancel. I'm left with x, which is the identity. They both came out to the identity, so yes, these are inverses. Alright, try this one. Hit pause. Come back when you're ready. No. Alright, if I try this, f of g of x, I start with g, which is the cube root of x minus 1, and I take that to f. So if I go to f, it says cube whatever you brought and subtract 1. Well, I brought the cube root of x minus 1. Well, the cube kills the cube root, and you're left with x minus 1 minus 1, which isn't just x, it's x minus 2. So, no, these are not inverses, because I didn't get the identity on my compositions. And you can see that here's where they intersect, here's mother, she doesn't intersect where they intersect, so nope. Alright, you try this one, hit pause, come back when you're ready. Hopefully you got yes. If I find f of g of x and g of f of x, here I'm going to start with g, which is negative 8 over x, and I'm going to go to f, and f is this, and I brought negative 8 over x that I plug in. Keep, change, flip. I have negative 8 times x over negative 8. They cancel, and I get yes. So I'm halfway there. G of f of x, the same darn thing's going to happen because the functions are equal. So I'm finding g of negative 8 over x, right? which says negative 8 over x, which is negative 8 over x. Keep, change, flip. Darn it. And I'm going to have negative 8 times x over negative 8. They cancel. I get x, which means, yes, they are inverses. And you can tell by the picture. The mother is the mirror of these two. Alright, try another one. Hit pause, come back when you're ready. Alright, so are they inverses? I don't know. We have to find f of g of x, and we have to find g of f of x. This says start with g. I'm going to skip some steps here if you don't mind, and take it to f. F says whatever you brought plus 6 divided by whatever you brought minus 4. And what did I bring? I brought g, which is 4x plus 6 over x minus 1. 4x plus 6 over x minus 1. 4x plus 6 over x minus 1. Alright, to simplify this mess, before I can keep, change, flip, I have to do the adding and subtracting on top. So I need a common denominator of x minus 1. So this becomes 6x minus 6 over x minus 1. Yes? So that would give me 4x plus 6x would be 10x. 6 and negative 6 cancel over x minus 1. On bottom, common denominator is going to be x minus 1. So on bottom, I'm going to have let's see, this is going to be, where can I write this? 4x minus 4 over x minus 1. So now on top, I'm going to have 4x, on bottom, the top of the bottom, I'm going to have 4x plus 6 minus 4x plus 4, because I got to distribute that negative. So the x's cancel, and I end up with just 10 on top. And on bottom, my denominator is obviously x minus 1. So now I can keep, change, flip, keep the 10 over x minus 1, change to times, flip that, cancel, the 10's cancel, and I end up with x. So now I have to check g of f of x, which I did not leave myself much room for. That was really stupid, Tamsin. See if I can fit it in down here. Alright, so g, so I'm going to take f and plug it into g. So my g function says 4 times whatever you brought plus 6 over whatever you brought minus 1. And I brought the f function, and the f function is x plus 6 over x minus 4. Alright. Yeah. Okay, so on top there, I'm going to get 4x plus 24 over, would you mind if I did this at the same time and distributed the 6 would give me 6x plus 6x minus 24 over x minus 4. Would that be okay on top? Hope I didn't lose anybody there. Alright. The 24's cancel, and I end up with 10x over x minus 4. On bottom, get a common denominator, which is x minus 4. And that becomes x plus 6 minus x plus 4, because I distribute the negative 1 over x minus 4. Combine like terms, and the x's cancel, and I get 10 over x minus 4. Keep, change, flip, I get 10 over x minus 4 times x minus 4 over, where's with x? 10. The x minus 4's cancel, the 10's cancel. I end up with x, which is the mother function, on both compositions, so yes. Alright, so how do you find composition of functions to determine whether two functions are inverses of each other? Well, if f of g of x equals x and f of g of x equals x, then we know that they're inverses to each other. Alright, on some homework help a little bit. What you would do here is you would switch. You could have two choices. You could either switch x and y and plug those in and see which ones work, or you could switch x and y up here and then plug them in normal and see which ones give you true statements or not. Okay, and on 47, right. Yeah, on 47, okay, they want you to remember the other day when we used the graphing calculator to do a regression. They want you to do it by hand. So your slope is going to be y2 minus y1 over x2 minus x1. And then you have to find your b, plug those two in, and you have your equation. All right. Hit pause, come back when you're ready. All right, so if we said let x compute the time in hours to travel x miles at 39 miles an hour, what does the inverse compute? Backwards, the miles traveled in x hours. Okay, do this one, hit pause, come back when you're ready. And hopefully you have 3, okay? It says let f of x compute the cost of a rental car after x days of use at 41 a day. What is the interpretation of the solution equals 153? Well, if f of x computes the cost, then the inverse is going to convert the number of days that you rented for that much money. Alright, I think we've answered everything. We're at homework, so we are done. Happy homeworking, and I will see you next time.